this slide presentation, I will be introducing high-performance liquid chromatography, HPLC, and discussing its significance in analytical chemistry. So, what exactly is HPLC? HPLC is a powerful technique used to separate, identify, and quantify components in mixtures. It is widely applied in various industries such as pharmaceuticals, food safety, and environmental testing. To understand how it works, let's look at some key concepts. Chromatography is the technique used to separate the components of a mixture. The chromatogram is the visual output or result of the separation process. The chromatograph is the instrument used to carry out chromatography. HPLC operates by analyzing compounds dissolved in solvents. It separates chemical in liquid samples, allowing for both qualitative and quantitative analysis of the components. Now, why is HPLC so significant? It is known for its precision and accuracy, ensuring reliable separation and quantification of components. HPLC is highly versatile, capable of analyzing a wide range of compounds dissolved in solvents. And it is the most commonly used chromatography technique in labs around the world, demonstrating its widespread use in scientific research and industry.
Principles of HPLC, also known as high-performance liquid chromatography, works on the interaction of two phases, which is the stationary phase and the mobile phase. The stationary phase is a solid material inside the column that slows down the components of the mixture based on their chemical properties. On the other hand, the mobile phase is a liquid solvent that flows through the column, carrying the components. Its composition can be adjusted to enhance the separation of different compounds, ensuring the accurate analysis. Next, HPLC also involved in three key steps: injection, separation, and detection. First, the sample is introduced into the system and then carried by the mobile phase. As it travels through the column, the stationary phase interacts with the components, separating them based on properties like polarity or size. Finally, each separated compound is detected and quantified as it exists in the column, ensuring the precise identification of the samples of components.
There are five components for HPLC. First is mobile phase, pump, sample inlet device, columns, and detectors. As for mobile phase, the mobile phase is usually organic or aqueous or mixture of both. It is filtered through a membrane filter to remove any particulate matter. There are two types of elution techniques. First is isocratic elution, where the mobile phase composition remains constant throughout the separation process. And the second one is gradient elution, where the mobile phase is changed throughout the separation process. This may help shortening the time for analysis and gives a sharp peak. Second one is pump. The pump is used to force the mobile phase through the column. The main criteria of the pump must be capable of delivering accurate and pulse-free flow rate, high volume of solvent, and high pressure up to 5,000 psi. There are three types of pump. First one is the screw-driven syringe type. Second is the reciprocating pump, and third is constant pressure pump. Sample inlet device. There are two types of sample inlet device, which is manual injection or automatic injection. The injection part consists of injection valve and sample loop. Next is column. Column is packed with various particles and is often unidirectional. It usually have 3 to 5 mm diameter of microcolumns. The types of column used in HPLC are guard columns and column thermostats. The guard columns extend the analytical column life and removes particulate matter. Meanwhile, column thermostat has temperature control and is common among modern HPLC. It also provides column water jackets, which helps in cooling or heating. Lastly, detectors. The characteristics of either detectors are high sensitivity, good stability, short response time, and low noise. And it also must be non-destructive and provides qualitative and quantitative information about the detected sample. There are 5 types of detector. First, there are UV absorption detector, which is the most sensitive. and widely used. Second is refractive index detector, which is not used in case of gradient illusion. Next is mass spectrometer detector, which is used with capillary column in analytical HPLC to give information about the nature of the material. Next is fluorescent detector, which is more sensitive than UV detector. And lastly, flame ionization detector, which is used for substances that have higher boiling point than mobile phase.
Moving on to the application of HPLC in food safety. First, mycotoxin detection. Mycotoxin produced by mold can contaminate food products. HPLC is used to detect this toxic compound in grains, nuts, and other food items to prevent health risk. Second, pesticide residue analysis. HPLC is used to monitor pesticide level in food products, ensuring they comply with government regulation and safety standards. This helps protect consumers from harmful chemical exposure. Third, quality control. Food manufacturers utilize HPLC for routine quality control testing to ensure that their product meets safety standards and regulatory requirements. Lastly, food additive and contaminants. HPLC can be used to identify and quantify various food additive, preservative, and potential contaminants, helping manufacturers to maintain product quality and safety.
Let's take a look at our conclusion. In conclusion, the HPLC's distinct mix of separation capacity, adaptability, high resolution, and sensitivity makes it an useful tool in modern analytical chemistry. It has an impact on a wide range of businesses, including healthcare, environmental protection, food safety, and many other essential areas. As technology advances, HPLC is expected to play an even larger role in future scientific discoveries and technological developments. That's all from us. Thank you.